Okay, in this recording, we are going to do Amtrak ridership, or we're going to forecast using a neural network. At the beginning, we are going to have our data, our libraries, simple, tidyverse, fable, slider. I'm not sure if I need slider or no, by the way, but I just copied it from the previous lecture. So also what I'm going to do is loading the data. So we loaded the data and we change it to Sybil. After that, we plot it. We know the time series of the ridership. After that, we are going to partition this into training and validation set. Note that I left the first 2 months. I did not use them because I'm going to use them as inputs. So I'm going to explain this in a second. To develop forecasting using neural network, there are many ways. We either include dummy variables or using deseasonalize first of the series, or we are going to include the 11 non-seasonal lags and one seasonal lag as a predictors. And this is what we are going to do this time. So we're going to use 11 non-seasonal lags and one seasonal lag as a predictors to be my input. That's why I left the first 12 months to be my inputs. Okay, so this is the plan. The second thing, what we're going to do, we are going to use, okay, if you want to neural network, let me just write this down. Neural network. For you to follow along, we are going to set seed equal 201. Any number works, but I mean, we choose the specific number, all of us, so we can get the same results. Why is that? Because the neural network will be used to create bootstrap samples of the time series. So it's going to do training of multiple neural networks and come up with the very best one, or the average of all of the networks. So that's why if you did not set the seed to 201, you're going to get different results that I do have here. If we did not set the seed to, the same seed, we will be all of us getting different answers. Okay. I hope this is clear. Now let's fit the model, fit neural network. So I'm going to use train data, pass it to the model. The model, I'm going to call it a neural. It's the function that we are going to use is NNETAR. Then my variable is ridership. And this can be, we can use one of the many syntax. So we can use comma, specify multiple numbers, p equals 11, p equals 1, period. We have 12, and number of nodes, specify this to be 7. I'm going to speak about all of these arguments in a second. It works. This is the default, by the way, which is 20. Okay, what is p, little p? Little p specifies the order of the non-seasonal AR, autoregressive terms. How many lags we are including as inputs. So lag 1, lag 2, because p now is 11, we are going to include until lag 11. These are non-seasonal ones, okay? If you did not specify this p, R is going to choose p based on the best fit AR, autoregressive model. If you did not specify it. In this case, we say, okay, let's have it 11 because we know our monthly data and we know the seasonality, by the way. That's why we said 11. This capital P specifies the order of the seasonal autoregressive terms, which is the number of seasonal lags. In this case is 1, which is going to be the default. I mean, if you did not put 1, it's going to be the default. And the seasonal lag is the last observed value from the same season. Because we have monthly data now, we put just 1 here, okay? We have P11 and P1. So that means we have lag 1, lag 2, lag 3, lag 4 until lag 11. Then this is lag 12 because it's a monthly data, seasonality every year. So that's why we said, oh, there's going to be 1, right? For the period, this is 12. The period specifies the periodic nature of the seasonality because we have monthly data. So that's why we said it's a 12. Number of nodes, in the hidden layer. So in the hidden layer, okay, this function only has one hidden layer, by the way. This function only fits with a single hidden layer. So number of nodes, we're going to specify this to be 11. And the default setting of the number of nodes is this guy plus this guy plus 1 divided by 2. So 11 plus 1, which is 13 divided by 2, and round it to the nearest integer. So that's why we said it's 7 here. Finally, we have the number of networks. As I said, number of networks is the default to 20, by the way. If you did not say 20 is going to be 20. So the function is going to train 20 neural networks. 20. Each of them contains 12 inputs, 7 hidden neurons, and 1 output. 20 of them. So it's going to generate 20 forecasts. After that, it's going to average them and to give you the best or not the final prediction. Is that okay? So if you run this now, we get the fit and N. You can look at the report. So this is the network, average of 20 networks, each of which is 371 network with 37 weights, linear output units. Sigma squared estimated as this. And let's look at the fitted, the data set, the the fitted values. So the first 11 or the first 12, we don't have them. Then we started getting the fitted value in month number 13 and so on, right? So let's look at the forecast. Let's do forecast. Because we did this, we built the model in the training data, using the training data. Let's forecast FC fit.and let's pass it to the forecast valid. Okay. Now we're going to specify, after the valid, I'm going to specify an argument which is times equals 0. Times equals 0, that means we're telling R that, hey, do not simulate any sample paths or do not generate stochastic replications. Just give me the direct neural network mean forecast from the ensample. You can just play with it. You can choose times equals, just change it and see how it goes. So this is a forecast. And after that, let's look at the graphs. Then we look at the performance measures. So let's plot. So I'm a track, just auto plot, and I'm going to add line. Static y equals the mean. What data? I'm going to use the forecasted data. This is for the forecast. For the color, let me use red. So what we got the auto plot first, which is the time series. Then this is my forecasted line, right? Also, let me add geom line training, okay? The training, we have y equals the fitted. From where? What is my data? Fitted dot fit dot nn, right? We can specify the color to be blue, because the blue is going to be in the top of the black, the original one. Let's have alpha to be 0.4. Then we can add the title, right? We can add the title, etc. Let me run this first. Here we go. So because the first 12 months we don't have data sets, right? These are they're used as an input first year, right? So look at how the training is almost on the top of the black. And for the prediction or the forecasting, doesn't seem to do well compared to the smoothing exponential in the past. The exponential, I think, did better than this one anyway. So to know how this guy does, we can look at the accuracy, right? So we can look at the performance measures, and actually we can compare what's called the accuracy on the validation and on the training. So let me find accuracy on the training. Let me add them. Let me add the accuracy on the validation. Okay. Let me bind them. Let me put them together. So let's bind row Combined rows. Okay, here we go. So look at neural network on the training. It's look at ME. It's almost zero. These are very small numbers, so it's clear that we are overfitting. This is overfitting. This is I mean, look at them. They're I mean, it's barely different than the black one. I mean, the original one, right? So it's clear that, however, look at the neural network, the errors have been increased drastically. So if you compare this one with the exponential smoothing or the linear regression we did, or the ARIMA, maybe others are doing better than the neural network. And this what we said in the lecture. The neural network does not. I mean, the the experiments or the studies shows that the neural network does not do very well in these cases. So this is everything about. I mean, we have many. We can do deep, so-called deep neural network, but or deep learning for forecasting. But there's gonna be, or I'm going to leave this to uh, for you probably if you like to learn more about the topic. So this is everything about using a neural network to do some forecastings for Amtrak dataset. Thank you.